Hey there and welcome to another TechHub.training solution video. My name's Nate and this is the solution for the Python challenge entitled Super Looper. So in this challenge, you're given this little block of Python script. What this script does is it takes a sample data frame of stock data, about 120,000 rows, and it iterates through each row in that data frame with this loop, and it does certain things to manipulate the data. It converts the date to a date time. It calculates the daily return, calculated as the closing price divided by the opening price minus 1, or the percent return for that day, and the trading volume of each stock on each day. And it also buckets those stocks based off of returns that have high volatility. In other words, the stock price changed greatly over the course of one day, medium, and low. Finally, you link the stock tickers that are in that original data frame to a data set that has the name of each company just for readability. And finally, it exports it to Excel. Now, as I mentioned, this is a pretty big data set of stock. And in this challenge, you were working for a management fund that wanted to be able to make decisions quickly. And if you know much about Pandas data frames, you know that looping through a data frame is the least efficient way to do it. In fact, with just the sample data set that has 120,000 rows, it took an estimated 2,894 seconds to complete just those few rows. Now, if you're working with millions and millions of rows of data, that can really add up. This is a number of hours right here. So let's jump into the solution. What you were tasked with doing is taking this really bad or inefficient code and making it run as efficiently as possible. So in my solution, you might have done this differently, but I just kind of went through these one by one. And there are many different ways to do manipulation on columns or rows in data frames that are much more efficient than looping. So the first one is converting the date to a datetime object. In this original script, it went through every row and it converted that value to a datetime object. Now, what you can actually do is you can, when you're importing the CSV file or an Excel file into a data frame, there's an argument called parse dates, and then you give it a list of columns that are datetime columns, and it will automatically put those in for you as datetime objects. There's no looping involved. It runs very quickly, and you don't have to do anything after this. Dates will just be in datetime format. Finally, one of the easiest things that Pandas data frames allow you to do are array manipulations or array formulas. If you picture a Pandas data frame in your mind, there are all these columns. All of these columns are just an array. They're technically NumPy arrays or Pandas series of data. Just think of them as long lists. And rather than going through each item in this list and performing an action on it, you can perform it on the entire list at once. So that's what this line does. Calculates the daily return as just rounding it off to 4 decimal places. The closing price, so that is an array of all the closing prices divided by an array of all the opening prices minus 1 to get the percent return for a day. Now, it doesn't matter if this data frame has 100 rows or 100,000 or a million rows. It will execute that one function on every row at the same time. It's a lot quicker, much more efficient than looping, and it cuts down significantly on the time. Next, we're going to go ahead and change the volume to numbers in millions. If you're familiar with the data set, then you know that each number is given as a decimal with the M after to mean in millions. So in the original, it takes this volume and it does a replace on each row, multiplies it, turns it into a float, turns it into an integer, and then saves it into that one row, and it does that for all the rows. Now, a better way to do this is to create a function called, in this case I called it convert volume. You can actually apply a function to an entire column in a data frame all at once. So like up here where we executed this operation, this expression on an entire column all at once. You can do the same thing, but there are certain things you just can't do, like using string manipulations. A lot of the times it will throw an error if you try to do it all in one line like this. So you can write a function, and this function can be as long as you need it to be, and then you just apply that function to a column in a data frame with this syntax. So name of data frame, name of column, dot apply, and then you pass the name of the function into the parentheses and apply. This gets a little hairy if you need to have any other arguments passed in besides here we're passing each value in each row of this column is passed into this argument here. If you needed more arguments, there is a way to do that. It gets a little bit more difficult, but you can look it up and find a good answer for it online. So that will go ahead and convert all of these numbers into integers in the millions. And now we have to note the volatility of stocks. So if you remember in the original, it just had a long conditional statement, and then it applied it again to each row individually. NumPy has this really cool method called where, and you can nest them. I really like to picture this as an Excel if formula. So if we're going to split these up based on high, medium, low, then what we're going to need to do is we're taking the total change. And again, I mentioned in the instructions that you can just trust the math that Jerry does here. So the high price divided by the low price, that's the total fluctuation in stock price. You can just use the same kind of calculation to get your volatilities here. The same thresholds as well. So what this basically says is np.where, picture that in your mind. I always picture it in mine as an Excel if statement. So if the percent change or the volatility of the stock for any day or any row in this data frame, remember, it does them all at once. If it's greater than 5%, then the value if true, just like in Excel, high. Else, the value if false, we can nest it here. So there's another nested loop that says, okay, if it's not greater than 5, now is it greater than 2.5%? And value of true, low, what's left, anything else will just be medium. You can nest as many of these as you need. It's, again, much more efficient than looping. Finally, linking the tickers to the names of the companies. In this original file here, you see it just loops through, and it actually, this is terrible because it has a nested loop, which sometimes they're necessary, but very rarely when you're working with a data frame is that actually necessary. A much better way to do it is just submerge the two data frames. This one was pretty easy. You just take the stock data frame that you've been working with, and you also up here import the company's data frame. It has the tickers and names. We want to left merge, which means we're going to keep in this left data frame here, the one that you introduce as the first argument. We're going to keep every row in that data frame. We're going to drop, if there happened to be a company in this data frame with a ticker that did not show up in the stock data frame, it would be dropped. So we're going to do a left merge on, and they're both named ticker. And we can get rid of that erroneous comma. That will merge the two data frames, keeping just the one column in the company's data frame called name. Finally, you can export it as to Excel if you'd like, just as a report. And all this just tells you how long it took. So if you remember here, Super Looper took almost 3,000 seconds to run. If we run my solution Looper, then we will see that it takes just under 14 seconds to run. Now, that's a pretty significant difference. Again, in the trading world or the business world in general, difference of minutes and even seconds can really mean the difference. So that there took 13.45 seconds. Might be different depending on how much RAM your computer has, or if you can find a way to improve my solution. I'd love to see if anyone can get it below 10 seconds. Please comment below. I'd love to see how fast and efficient we can make this little bit of code. Thanks so much for hopping in on the solution to Super Looper, and have a wonderful day.